Hello, everybody. All right, so today we're going into logarithmic functions. So let's look at what we're going to be covering here. We have a lot of things to cover. We're going to change back and forth between logs and exponents. We're going to evaluate and use basic properties. And then we're going to do a little bit of graphing and talk about domain and talk about natural logs. So let's get right into this. And we're going to start off with the change of log form. So the definition of a logarithm. All right, so if you have a logarithm, you have this property here that says if you have a traditional log that looks like this, you can actually change it from this log form to this exponential form. And the vice versa is true. If you have this exponential form, you can change it back into this log form. So it's just like this circle here. Now, reasons why we might want to change it from a log to an exponential, it might be easier to solve the equation in an exponential format versus in a logarithmic format. So just by taking a look at this and looking at how things are written, your life might be a little simpler by changing it from log to exponential or exponential to log. Okay. Um, so when we get into here, you're going to notice that this b here, this is going to be your base. This is also going to be the base of the exponent. So those two match up. This is what we're actually going to wind up equaling, and this is going to be the exponent. So when you're trying to rewrite and go back and forth, you're going to basically be doing it into this format. So notice the colors. So log b, well, there's my b for my base. X, that's what we're equaling, and c is my exponent. So what I want to do is I want to take each one of these and I want to change these into exponential forms. So I notice that this is my base here. That is the exponent, and this is what I'm going to be equaling. So when I rewrite this as 7 to the third equals x. Now, depending on the question, I could be done, or I might be able, because this is something that I can actually solve, I might just want to go ahead and solve what 7 to the third is. And so, you put that into your handy dandy calculator. And when you get your answer, you should wind up with x is equal to 343. So again, let's try it with this one. This is my base, that is my exponent, and this is what we're equaling. So I have a base raised to the power of 2 is equal to 25. And so again, if I wanted to solve this, to get the b by itself, I'm going to take the square root of both sides. And when I do that, I get plus or minus 5. Now, when you're taking a look at this, one of the things that you have to notice is that your base, so you have to remember what we talked about in the last section, bases can never be negative. So when you write your final answer for this problem, the base is only going to be the positive 5. Because remember, you can't have a negative base. So even though you wound up with two answers right here, that negative answer we can't have. So that only lets us be the positive 5. So take a few seconds, pause the video, and see if you can come up with a way to rewrite this next one here. Okay? Ready and pause. All right, welcome back. Let's see how we did. So if you did this correctly, you wound up with 4y is equal to 26. There you go. Now, because you don't know the steps to be able to finish this yet, you're just going to leave it just like that. There's nothing else for you to do. So there's no way to solve it. Here, you could solve that relatively easy. Here, you could solve that relatively easy. But here, you can't, so you just stop. All right. So now, that's log to exponential form. So let's look at when you're one of your homework questions from your actual homework will look like. So if you take a look here, this is kind of already solved out for you. So all you have to do is write the equation in the equivalent exponential form. So again, that's the base, that's the exponent, and this is what that equals. So we have 8 to the power of 3 equals 512. And that is what would go into that box right there. All right. So now let's go backwards. So I have exponential form, and I want to rewrite it into log form. So again, remember, this is my b, this is my c, and that's obviously my x. So I'm going to say log, that's a base of 2, and this is what I'm equaling, of x equals 5. And that's all it wants you to do. Just wants you to rewrite. So again, I have log base of b of 27 is equal to 3. Okay, let's try this one. We have log base e of 33 is equal to y. Okay, so that's all it's going to want you to do is just take it from the exponential format and put it back into the log format. Okay, so again, same type of a problem here. So we have a log base 4, that's of 16, is equal to 2. And that is what you would put right there. All right. So that's the first part of your homework that you're going to wind up seeing is going back and forth between all this. So now let's talk a little bit about evaluating. So what's going to happen is they're going to give you a logarithmic expression and say, hey, I need you to solve this for me. The thing is, though, it's not equal to anything. So what you have to do is that you have to go in and set the log expression equal to something. So your x, a y, your favorite letter, whatever it is, and you just set your logarithmic expression equal to that, and then you rewrite it to exponential format and solve. So if I have this, I can't do anything with the way this is written right now. So I need to set this, and just pick your favorite letter. I'm going to use X just because. All right. So I'm going to set that equal to that way right there. Remember, this is my base, that's my exponent, and this is my answer. So I have 10 to the x is equal to 100. All right, so basically it's asking, what does my exponent need to be to equal 100? So what I need to do is say, okay, can I come over here and rewrite this 100 into a base of 10? The answer is yes. So I have 10 to the x is equal to 10 squared. Because both of my bases are exactly the same, I can drop my bases and set my exponents equal to each other. And then there you go. Okay. Let's try it again. Now this one has a fraction. So we'll deal with this in a second, but again, pick your favorite letter. Let's pick a different letter. Let's do an M. I like M's. M's are fun. So I have 5 to the M. That equals 1 over 125. So now I need to take this 125, and can I turn this 125 into a base of 5? The answer is yes. 125 is going to be 5 to the third power. Then what I'm going to do is I'm going to take my exponent rules, and I'm going to say, okay, so I've got 5 to the third power here. It's on the bottom. So what I want to do is I want to turn this back into something that looks like this right here to get my bases the same. So I got 5 to the m here. So that means I'm going to have 5 to the negative 3 there. Because remember, when I take it from the denominator and I bring all this up to the numerator, I can do that as long as I change the sign of my exponent. Now I have my bases that are exactly the same, so my m will be equal to -3. And that's it. You're done. All right. Take a few moments, pause the video, try this one. Go. Welcome back. So let's see how you did. So on this one, let's go with a K. Ks are fun to write. So what I have here is I have 36 to the K is equal to 6. So I need to basically take this base here into this base over here. Well, the problem is I can't really do that. But what I can do is I can't turn this 6 into a 36, but I can turn that 36 into a base of 6. Okay, so what I do when I do that is I wind up saying, okay, well, 36 is the same thing as 6 squared. So I have a base of 6, and I know that's a squared. So I have 6 to the 2k is equal to 6 to the first. So when I'm sitting here and I'm looking at this, I said, okay, so on this one here, like when we were back over here on this one, we were always rewriting the right side over here. Well, on this one, we have to work on the left side because I can't turn a 36 without changing the problem. I can't turn a 6 into a 36, but I can turn the 36 into a 6. And since I already know I've got that k sitting here and I know I can rewrite 36 into 6 squared, that's where this 6 to the 2k comes from. Again, I have my bases that are the same, so I have 2k is equal to 1. So my k is equal to 1/2. And if you think about it, that makes sense because what's the square root of 36? The square root of 36 is 6. All right. One more. Okay. So same thing. Let's go with a z. Z's are fun to write too. So I have 3 to the z power, and that equals 3 to the, now mind you, I'm going to rewrite this into an exponential form, 1/7. So that means my z is equal to 1/7. All right. So when you're trying to evaluate, the key thing to remember is that you need to bring in your favorite letter so you can represent basically your exponent. So when you're sitting there, what you're basically doing is solving the exponent for these logarithmic functions. Okay. All right. So in your homework, you're going to have something that looks like this. So it's the same thing. Pick your favorite letter. Let's go with a B. So I have 5 to the B is equal to 125. So when I solve this, it's saying, okay, I need to turn that 125 into a base of 5, which is 5 to the third. So I know that my B is going to equal to 3. So the 3, only the 3, this right here, is what's going to go on that little box. Okay? All right, moving right along. Log properties. So we have a few log properties that you kind of need to know. Good thing is they're not hard, but what I would do is make sure you have all your properties in the same spot because these properties are going to kind of look the same. They have the same characteristics to it, just to let you know. So anytime you have these two that are going to be right here, if they're ever the same, you're basically going to have a setup that looks like this. So that means if I have b to the first power is equal to b, that is what I'm going to wind up with as an answer. So that means whatever it is I'm solving for is going to be the same thing. If I ever have my logarithmic set to 0, then I know that my answer is going to look like this if I have to turn it into exponential form. But if I don't, so what's going to happen is they're going to give you a couple of different properties, and it might look something like that. So when you have log b to the b or log 7 to the 7 or whatever else, you know when that happens that your answer is simply going to be 1, and that's because of this exponential piece right here. When you have log b to the 1, again, because of this property right here, this exponential property right here, you know every time you see that, doesn't matter what it is, if it's log 7 to the 1, you know your answer is going to be 0. Because remember, this is your base, that's your exponent, and this is actually what it equals. So again, if I'm looking at this, my base and my x value are the same. And so if you go back and take a look here, I know that this answer is simply going to be a 1. When I'm looking at this one here and I apply my properties, I know that this answer is simply going to be a 0. And that's all you need to do. You just need to know your properties here. So when they match, it's a 1. When this is a 1, it's going to be a 0. Okay. Then we have these inverse log properties. Basically, what that's saying is, again, if you have your two bases, your log of b, and that's raised to the x power, your answer is simply going to be x. And the same thing up here. If you have your exponent raised to something, whatever it's written over here is just your answer is going to be x. So if I'm taking a look at this and I'm working on my properties, I notice that these two are exactly the same, so my answer is just going to be an 8. When I take a look at this one here, I notice that this and this are exactly the same, so my answer is going to be 17. And that's just following the property. As long as those are the same, then you don't have to worry about anything else. You just write whatever that number is or letter is that's right there. Okay? So now, let's look at domain. So the domain of an exponential function in the form of f of x equals b of x includes all real numbers. And the range is a set of positive real numbers. Because our log functions reverses the domain and range, the domain of the log function is a set of all positive real numbers. So basically, if you think about it, the range of your exponential is going to be the domain of the log, is what this is basically saying. So when you take a look at this and you actually go through this process or whatever, as long as it's in this format right here, then you're going to be you basically would say that because this isn't what my format is, my domain is going to basically be x is greater than 0. Okay. So when I take a look at this piece here and I want to know what my domain is, well, first off, I know that logs always have to be positive. I can't have negative logs. So if that's the case, I have to look at this here and I say, okay, I have my x minus 5. I'm going to set that equal to 0. And then I'm going to solve for this. X is equal to 5. And so when I take a look at this, what I want to notice is that I'm going to, instead of starting at 0 and having 0 comma to infinity, I actually have to start here at the 5. But I cannot include that 5. So my domain goes from 5 to infinity, because I need to make sure that this whole entire thing never goes to 0 and it's always going to be positive. And so in order to do that, you have to solve that, get that answer, and then when you write it in interval notation, not greater than and less than, interval. So when you write that in interval notation, you're going to start there and it's going to go off into positive infinity. All right, so just pay attention to what it's asking you to do and just solve that inside piece. So in your homework, you're going to, again, have problems that look like that. And so notice I don't care about this log 8. That part doesn't bother me. What I need to focus on is going to be that x plus 1 right there. And so with that x plus 1, I come over here and say, all right, so I've got x plus 1. I'm going to set that equal to 0. So x is equal to negative 1. So that means my domain starts at negative 1 and it's going to go off into positive infinity. Mind you, I do not include that negative 1 because that you cannot have a log that's equal to 0. All right. So let's talk about the common log. So the common log is actually extremely easy. When you look at a common log, if it is common, it's not going to have anything written here. So if you notice, if it's a common log, notice there's nothing written here. That implies that you have what's called a 10 there. It's your base 10. So it's part of our counting features if you think about it. So anytime you just see log of x or log of, x plus 2 or whatever else, just know that log has a base of 10. Your calculator can solve common logs. It is set up and designed to be able to actually do that. So again, looking at your properties of common logs, it's the same stuff. All right. So the only difference is when we talked about properties earlier, there was a B here. In this case, there's just a 10 there that you just don't see written. It's just implied. So notice they are exactly the same things. The only difference is now there's a 10 versus any other base that you can have or want there. So when I'm looking at this, notice that there's a 10. So go back to your properties. So when you see all these things that are sitting right here, notice that number 3. Remember, that's the same thing as saying log of base 10 of 10x. Well, that will equal x, okay? So when I'm looking at this one, remember that is log base 10 of 10 to the 8, which means my answer is simply going to be 8, and that is what's going to go in that little box right there. Okay? Natural logs. So for natural logs, your properties are going to be virtually the same as the other ones. The only difference is what it looks like. So we've been writing log for logarithms this whole entire time. But when we have a natural log, we look at it in the form of ln. So that's that number. It's the button right next to the number 4 key on your calculator. When we write ln, we know that we are talking about something in the terms of a base e. So to represent our e has its own little log function. It's called natural log. So when we see natural log of x, we understand, and it's implied that's really log base e of x. And if you look at the properties here, it's the same thing. The natural log of 1 is 0. Natural log of e is 1. And then they have the same inverse properties as everybody else. And if you take a look and notice how that the natural logs connect with the general logs, you can see the characteristics and the properties that go back and forth between them. So when you have this problem here, the natural log of e squared, so again, if I have the natural log of e squared, so that's going to be this number 3 right here. My answer is just simply going to be the 2 because that's what the exponent is. So when I'm looking at this, my exponent's the 2, so I just write in my little box 2. When I have a fraction, that's okay. Just rewrite it to where the e has a negative exponent. So you have the natural log of e to the negative 21. Now this turns into the problem that we looked at a few minutes ago, which means that my answer is this negative 21, and that's what goes into that box. Okay. All right. So that is log properties, log functions, and everything. So these are your bases. Get into your homework and start working on that. The only other thing is the graphing piece. All you need to do is plug it into the calculator and match the graph. That's what the questions look like on that one. All right. Make sure if you have any questions, you're sending me emails, you're shooting me a remind to ask me questions as well. So that way I can get back in touch with you. All right. And with that, I hope everybody has a great day, and I will talk to you soon. TTFN. Ta-ta for now.